Hi, good morning, everybody. My name is Bhaskar Tamma. I am the professor and head of Department of Mechanical Engineering at Mahindra University, Equal Central School of Engineering. So I'll just try to share a few things about what we do here and how the mechanical engineering and mechatronics play a significant role in terms of how we develop things, right? And what is the relevance of these courses to any of the product development and others. And we will, while we do this, I would appreciate if you can post your questions in the QA box so that we will take the questions at the end of the discussion. Okay, Tom. Okay, so let me sort of minimize. So we'll discuss about the mechanical and mechatronics programs today. We'll give a bit of introduction on how they are relevant and what goes into making these programs and how can this be a successful program for the students who join, right? We'll just start with an example. So last year when COVID started, we were looking at how do we come out with an product that can actually minimize or eliminate virus activity, safe to operate with minimal intervention. And we are also looking at how can we make it more ease of use and serviceability, right? So we had one of our bachelor student Vishal helping us build this. So it's almost using whatever he has learned in the undergraduate program and the things that he learned on how to build the things based on the fundamental physics. So there are a lot of things that came together in building this. You have the UV lights trying to deactivate the virus. We have a power source. We have other things like motion detectors, sensors, and all to make sure that the autonomous vehicle moves, maps the area, and then moves to desired locations and then perform functions, right? So when we look at that and see what are the elements that goes into it, it has structure to hold things, it has wheels to move it, you have motors to activate the wheels, you have sensors and signal processing, then we have the energy management to make sure everything works fine, right? And to bring this all together on building, the key things is, you identify what are the functions that are needed based on the need. And then you go ahead and design the geometry and with appropriate materials that goes into it. Then you do the manufacturing of parts and assemble it, and then finally control it to the desired function, right? So these are the key elements which actually goes into looking in the mechanical engineering, right? So if you want to build something physical, right, mechanical engineering disciplines are the key, right? So even if say, okay, I want to control some things, so I don't need anything, but yeah, you need a computer, you need a lot of physical hardware that goes with the computers and the chips and everything. And for that, you need manufacturing, you need thermal management. So whichever, if there is a physical object, you definitely need, which needs to be controlled to do a certain functions, then you need a particular discipline of mechanical engineering, right? So next, moving on and say, okay, we have an object and how do you control it? Then comes the mechatronics part of it. So if you have a physical device, right, like we have a robot here in the lab, which actually performs certain functions. Okay. So what is the key thing in this is like it is trying to pick objects and place at certain locations. So which essentially means you need to see what you want, which function you want to do. So you need a sensor, then you need to convert the signal to a digital one. You process and say, okay, what do you want to do? And send the signal back to an actuator, which is the arm and the pneumatic line. And that will go and make sure that the physical device which you want to perform certain functions to do it, right? So this is how, if you look at any equipment or system that you are looking at, you need to do all this to perform a given desired operation, right? So what does it involve? It requires sensing. You need some transmission. You need to compute, do certain computations to say what to do next. You need to act, which essentially means like you want to move in a particular direction and all. And then you need an energy to do it, right? So with all these things coming together, right? You need different systems that needs to come together to perform certain functions, right? So how does this all happen, right? Over a period of time. So if you look at the evolution, right? Let's take an example of cooking. Earlier, there used to be some vessel, you supply energy and then, you boil things or cook or fry. Now, currently, you have most of it automated. You could do multiple functions. You can track. You can automatically regulate what temperature you want to set. You can also regulate how long it should be. And then after it cooks, you go into a warm mode and all. In future, you just say, okay, you just put it and automatically it might detect what is the object, and then you say, I want to cook this. It would automatically set everything, track how it is being cooked, what is the state, and based on the state, automatically ready, right? So this is how things are evolving. And let's take one more example, like a camera, right? You had photo films, frames, then went into films, and then now everything is digital, right? If you look at phones, the basic purpose was only to dial, which was used to have a mechanical dial. Then came digital pads, and then now it has become very, handy and very small, right? Now you combine these two functions. What you'll end up with a smartphone, right? And in future, you may see, it may be flexible. You will not have a bulky one. You can have just the display and a transparent screen, right? So what is changing? You started with something which are like bulky and a single function. These systems are very complex. There's time consuming. You had little or no control. So the only way is you have to manually disconnect things or remove the stimulus that you are giving, right? And you have to continuously monitor. From there, we have reached to a point where we are trying to simplify things, make it compact, combine multiple functions of different objects, right, or machines. Control is good and monitoring is less. Future, you're looking at something which is modular, which could be used for multiple purposes. And these machines would learn and adopt themselves and would require less monitoring because you train them. And what is key to this is a combination of mechanical and electronics and computation coming together. Okay, so what are the applications for this? You will see different applications as in appliances, business, you see printers, accounting. You will get into applications in banking, healthcare. This is pretty high, that is going on for a long time, and it is evolving pretty fast. You could see Da Vinci is one of the latest one based on mechatronics, which does operations based on predefined requirements very precisely. Exoskeleton, here is where this is something which has been developed by one of our faculty, Professor Deep Say. which helps for people who have the function of the limbs going down because of paralysis or aging. So how do you revive that? Exoskeleton, an industry where you could move heavy things. Autonomous UV sanitizers, this is something Prasadeep has developed with the student. Agriculture, smart farming, right? That is the keyword right now. So how do you increase your productivity and do need-based monitoring as well as diagnostics, and then take action? Because this is very key for improving the productivity and timely, putting fertilizers and pesticides as required. This is growing very high, and the mechanical department, mechatronics, works with the electrical department in terms of how do we deploy this using 5G and IoT. Transportation is other one. So the one which you see on the left here is an underwater autonomous vehicle where you could deploy this to look at how things are changing within the sea. This is something that our team has developed along with the students. So we'll talk about that in a bit. You're looking at a lot of electric vehicles with vehicle-to-vehicle connectivity, right? Drones, which are gaining a lot of popularity in terms of monitoring, right? Manufacturing. This is the other area where mechanical and mechatronics are playing a significant role. You have robots which will pick and place. You have 3D printing, both metals and non-metals, which help to actually build print complex structures, which a typical conventional manufacturing process would require multiple parts to be joined together. Right? So there are a lot of wide variety of applications where both mechanical and mechatronics play a significant role. Now, if you look at mechatronics, what are those things that are required, that go into to make a mechatronics engineer? You have the mechanical part, where you have the mechanical design. You need to know about mechanics, materials and manufacturing, and hydraulic and pneumatic systems, which help in terms of actuation. The other arm for this is the electronic control, where you have the microelectronics, embed systems, you have the actuators and sensors, which is really important. And as we looked at in the first slide, we have looked at how we need to get the signals from the sensors, use digital signal processing to process those signals and convert into a form that is sensed by the actuators, and then you have the final function to be performed, right? The other part of it is the computational part, because with so much data coming in, how do you automate it? How do you frame the data so that you can pick and choose for relevant operations, right? And yeah, then bringing all this together. So we are bringing mechanical, computers, electronics, everything together. So the key thing in this is to have a very system level understanding and how to bring this together. Here is where the systems engineering helps a lot, right? And while we do this, the key thing is to do it with highest integrity and ethics, and also make sure that the project is done on the right time, right? So essentially, if you look at mechatronics, it's an integration of mechanical, electrical, and computer science. And now we look at how do we actually implement this, right? One thing is to say, okay, here is what mechatronic means, what are the disciplines, where it is applied. The key thing is finally implementing it into an undergraduate program, right? Typically, the way we look at it at Mahindra University is in the 4 years of undergraduate program. The first 2 years are looked at, learn the basics and apply to scenarios. And the third year is for building systems and the final year is to demonstrate learnings, right? The first 1 to 2 years, the first 2 years is spent in terms of basic science and engineering, and then second to final year is more on core engineering, right? And the final year is for projects and internships, right? So we encourage a lot in terms of students going for internship, and the key thing is, how does industry look at it? The key thing is to get the pre-placement offers, and then as a part of that, the final 6 months of the final year, they actually go as interns, work with the industry, assimilate the working culture, and then demonstrate how the application of basics to the industry applications, right? This is something Mahindra University encourages a lot. So all pre-placement offers come with an internship of 6 months in the industry, right? And while doing this, the key thing is, how do you train the students in terms of communicating? How do you collaborate with others? Professional ethics, and how do we do good to the society while doing all this, right? And there is always a continuous progress assessment to make sure that the students are gaining the requirement skills. And finally, the key aim is, when you look at any engineering program, is to first help define the problem. So if they come across, when they go to industry or anywhere, first define how the problem is, what the problem is, what does it require, and then equip the basics to solve it, and then train them how to approach to problem solving, right? So these three are important, because once a well-defined problem is half solved, right? Basics and problem solving skills is something we train them for, so that given any problem, they would follow a systematic procedure to arrive at a solution, right? Who are the enablers for this? So we have a very strong team of faculty at mechanical department. All our faculties are PhDs from IITs or abroad. That's something, the management believes in, that a well-trained researcher with incredible credentials are key. We have from, the faculty from different streams. They have a mix of analytical, computational, right? And also experimental methods. So we have a mix of faculty who do both also, so that we have strong in both theoretical as well as in terms of demonstrating through experiments. And most of the faculty work in pretty evolving areas, like robotics, solar, smart materials. Electric vehicles is something we are going high in collaboration with our electrical department. Microfluids for both healthcare and other applications. While doing this, the faculty have a lot of funded projects. We just crossed 100 lakhs just last month, with significant funding from the Department of Science and Technology. Publications in highly reputed journals. Because of the caliber and the evolving areas, we do have PhD students coming in from last year. So that shows the strength of the faculty, the university, the research facilities that we have. And we also, to get a better understanding of the industry, how it performs, and how is the theory that is learned actually is applied in practice. So we have guest lectures from industry experts who come and talk about different physics that are used in industry and how they are applied, and how is it relevant to what they are learning and the skill set. And also we do have industry collaborations within Mahindra Group. We have Mahindra and Mahindra Research Valley, Mahindra Electric. We also collaborate with Daimler and also startups. So it shows the depth and breadth of the faculty in terms of industry collaborations as well as the research, and also how do we bring these skill sets to the students so that they benefit, and when they complete their undergraduate program, or have the required skills. The other enabler is in terms of the labs. We have very advanced labs for undergraduate programs spanning manufacturing, mechanical materials. We have the full systems like the automotive system, and also in terms of computation, we have the finite element analysis lab and the computing facility. The other one is the students are also encouraged to do research projects, right? So we have seen students coming in at second year and telling, they want to contribute. So initially there is a hand holding with their seniors so that they get to know how things work. And then slowly when they come to the third year and final year to do their projects, they are well versed, comfortable, and ready to go. So we have set of research labs spanning, fluid thermal. We have a good computational lab, material testing. We are also going high on design and prototyping lab in terms of 3D printing. So essentially, when the student has an idea, he comes to the lab, builds the structure in CAD, then analyzes for fluid and thermal. And once he is confident, then there is a 3D printers. We have 3 of them through which they can print and assemble and see if it meets all the requirements in terms of assembly and functions. Then they actually go and build the actual one. Robotics, which is pretty current and evolving. So we have industry grade robots. We have the Stewart platform to look at the dynamics, and also the right one is something that the student and faculty keep building to try different concepts. So next comes like, okay, we have talked about what are the requirements, what is mechatronics is all about, and who are the enablers like our faculty, what are the facilities. Now, how have our students performed? The test to that is how did they reduce to practice whatever they have learned in terms of the fundamentals applied system level and doing through projects, is in terms of publications, products that they have developed. Are they able to compete, build things for a given requirement? Because these are things that when you go to a competition, it's about a problem is defined, but nobody knows the solution, right? So that's where bringing together all the things that they have learned, apply them, come out with the different solutions, try them, and finally make it work, right? The competitions do help in that. And most of the students are pretty high in terms of acquiring additional skill sets. So Six Sigma certification in terms of green belt is for quality. A lot of students go for that. And here are a few things that our students have been doing in terms of developing autonomous underwater vehicle. In SAE Aero, we have the Baha. Last 3 years, they have been competing in this, slowly year on year, evolving, learning things as they build, because most of it is with their ingenuity and hard work. So most of the students, since they are in campus, they spend their time after the classwork to come to the labs and work in building this. And the key thing is they also come together and say, okay, we want to share with others what they're doing. So we have the newsletter where we have students from all the 4 years coming together, trying to collate material and then releasing it as a newsletter, right? So that is on the publications product developed. How are they faring in real life? We have a lot of students who are placed, and then a significant amount of our students actually go for higher studies. So we have people who have gone to Columbia, Texas A&M, Ecole Central France, who is our collaborator, Shamas. So these are pretty highly rated in the rankings. So what they have learned, what they have experienced in terms of research and building things have motivated a lot of them to actually perform better, look for higher studies. Right. Finally, Mahindra University stresses more on rigor in the academics, bring together the left side and right side of the brain, so that they end up looking at not only the conceptual but also the implemental aspects of things, life skills in terms of communication, collaboration, work with integrity, go out and then do what they want, right? And provide the required industry exposure so that they know how things work. So even some of the students do end up pursuing the entrepreneurial path. Okay. So from the Department of Mechanical Engineering, we have the two courses which we talked about, the BTech in Mechatronics and in Mechanical Engineering. Okay. Now I'm open for any questions that you have. So can you post in the Q&A?
Request the attendees to type in your questions in the Q&A chat box.
I know a couple of participants did try to raise the hand. Sorry, I was like, concentrating on trying to share from our side so that the next 30 minutes we could, have a fruitful discussion on the Q&A that you have. Yes, Vinod Kumar, can you type in? Okay. So this is a question from Agnimitra Sinha. System of advance offers based on predicted grades in IBTP2. I think I will let Rakesh handle it. Ninad Kulkarni, criteria for admission for course in your university. I think Rakesh will be handling that. And Subranil Saha, right? You mentioned about CSE student of first year, how can I go into field of AI and robotics? I think since you are already in computers, I think this we are looking at mechanical and mechatronics. So AI and robotics, I think we will let the CSE department talk about it. So an attendee has demand for mechanical engineering or mechatronics, right? So which has more demand? Good question. So it's a very interesting question, because how can you gauge a demand, right? Both are key disciplines, right? And most of it depending upon at what level. So we have seen like mechanical engineering, I spent 20 years in industry. Initially it looks like, yeah, mechanical engineering may not be demanding and all, but as you grow and develop expertise, you will see that you will end up doing a lot more bigger things and a lot of demand. So you will see demand for both, because you need to build things. How will you build if you don't have manufacturing, if you don't know how to use materials, or if you don't know how to design, right? Each has its own strength, and each, required. So it all finally depends upon what is your interest. Do you want to build things? Yeah, mechanical engineering is the way to go. If you say, okay, I want more on automation and then look at robotics and others, mechatronics is the path. See, both have their own, strengths. Defense and health by robots and AI. Yeah, mechatronics is something, Subranil Saha, you can look at. Sorry, this is Vinod Kumar Yadav. Are you working in the area of wax modeling, using robotic arms and additive manufacturing? Robotics, yes. In manufacturing, that's something we are looking into. Wax modeling, it comes under a bit of, so I need to understand a bit about what does wax modeling mean, because wax in the different senses and states, you could model using fluid dynamics and heat transfer, right? And then if you say, okay, do you have wax modeling and can you do with additive manufacturing? Yeah, maybe. It all depends upon the temperature and the geometry that you want to do it. Were there any other questions? I'm just scrolling down. Okay, so this is Riddhi Sitlani. Mechanical engineering is generally not considered a field not for females. Is that so? It's very interesting question, right? It's about mindset, right? Mechanical engineering, okay, way back in 80s when I was doing my graduate, we had the first female mechanical engineer in our class, right? So somebody asked the question, why did you choose? I'm interested, I took it. And she used to, work and compete with all of us. Nowadays we don't have foundry or, smithy. At that times we used to have foundry and smithy. And she used to compete with us and do much better than us, okay, or equivalent to us. We never felt like, yeah, no, female shouldn't do. She had the right attitude. She told, I like this area, I'm going to do it. And she did it. And recently, like a week back, I was in Mahindra and Mahindra Igatpuri manufacturing and assembly plant for engines. I have seen at least 10 to 15 girls. They were actually, working equivalent to the other assembly things they were doing, looking at CNCs, material testing. They were in the assembly line assembling, right? The engine components. I was really surprised. I never seen a mechanical or an engineer in a workshop or shop floor assembling things, right? Things have changed. If you have the right attitude and say, okay, I like this and I want to do this, I think a lot of industries do encourage, diversity in terms of, females working in all the fields. So the limit is the motivation, right? And your desire to say, I want to do this. Okay. So the generality that has been a self-imposed constraint is what I look at. They say, okay, we have to lift, we have to be doing smithy, we have to, do a lot of heavy lifting and do. If you feel, yeah, we can do it, there's nothing to stop, right? So I hope I answered, your question, Riddhi. Because there is no area that is, that is not suitable or not relevant to females. There's nothing like that. So the next question is Saubhagya didn't have computer science in class 12. Eco with science, will mechanical or mechatronics be difficult? No, because when you look at the curriculum, you start with looking at the basics of physics, right? We do have, if you look at the first 2 years is a transition period from, whatever you have learned in your class 11th and 12th to getting the basics into engineering. So the first 2 years are spent in reinforcing what you have learned or not learned during your 11th and 12th, with major emphasis on application, right? So how do you apply for either mechanical or mechatronics disciplines? So I don't think not doing a computer science in 12th is a hindrance for that. Yeah, you can go for either mechanical or mechatronics. No problem. Subranil Saha, I can contribute in that field of by course certifications and off-campusing. The key thing in this is, I know we do encourage students to do a few certifications and internship. The main thing is like we provide the basics, the applications, right? But industry requirements include some of the requirements would require hands-on experience, because it requires how do you use what standards, working for people together, where to lay emphasis on which part of the problem, right? Because that depends upon the need of the industry, right? Some of the certification courses would help, but the internship is the key, and we do encourage on that. Pratik Pawar, engineering is to work at workshop, not necessarily, right? See, the key thing is when you have to build things, right? You need to design, you need to manufacture, you need to assemble, right? You could be at different levels, right? If you look at, okay, can I go into the assembly line, shop floor and do things? If you are good in CNC machining and all, you will be looking at how to program, make sure the right products are made with the required tolerances, surface finishes and all. That's where you could do. And you can see how to automate, right? So when I mean either workshop or shop floor, it's actually a shop floor of the assembly lines and all that, right? The contribution could be, doing directly based on your skill level, right? If you master in a few things, you go and look at, you go upstream and look at how do you design. Is there a lot of depth? So this is from Rahul asking, is there a lot of depth in physics for mechatronics? See, when you look at physics, there's a lot of emphasis on the basics and fundamentals, right? This is the key. If you say, okay, I may not go deep in physics and I don't have the appetite, then that is a challenge for any engineering course, right? Because in physics you look at fluid mechanics, dynamics, mechanics, strength of materials, right? So a lot of things come together, optics, right? These are relevant somewhere as you go along as in engineering profession. So a strong physics is really important. That's something you need to master. And in the first 2 years, we do have the physics as a part of the curriculum, which should help you to catch up on that, right? Mechatronics, definitely physics would be the key, because you are looking at sensors, actuators and all, in which case a lot of the physics relevant subjects would be very, very important. Okay. Have I missed any questions? Yes, please. Any other questions that have come? Pratik Pawar, I'm confused between computer science and mechanical engineering. Okay. Let me see if Rakesh is handling that. So, Pratik, I need more clarity on this. Confused between computer science and engineering. Are you still not clear on what does computer science will involve versus what mechanical engineering is involved? But let me generalize this a bit and say, when you look at the different programs that are offered, one is your interest, right? Is your interest to build things, make them work, right, and see how it goes in a physical world? Then mechanical engineering is the way. You say, okay, I want to deal the handling data, information, and how to go about it. Then computer science is the way, right? So it depends upon what is your interest, right? Because I know there are different people who have different perspectives. I wanted to build things, right? So though I did my PhD doing a lot of simulations, I told I want to build things and see how they work. So immediately after my PhD, I spent 2 years with Mahindra tractor R&D, looking at how things are, built. How do you design, go about, making sure how they perform better in different environments, like, very dusty environment, slushy environment, like farm fields, right? And then I told, okay, I want to do more. So I joined the G Global Research and told, okay, I know a certain physics. Can I expand this physics in terms of diesel engine combustion emissions, and then apply the basic spray combustion and emission character, physics to other applications, right? So that's where in G Global Research, I was able to expand the applicability of a given physics to, I worked in appliances, compressor programs, worked in locomotives, right? Healthcare, right? The key underlining physics in all this is like, is it a flow problem, thermal, structural? Is there energy release, right? And how do you contain it, right? If you are strong in this physics, right, you could say, okay, I could apply not to one, but to multiple applications. So that's what I learned. Sometimes what happens is we do tend to attach to a particular product or a particular area and say, okay, I don't know about others. But the underlining is, how do you define the problem? Do you know what it requires, right? And do you know the approach to the problem solving? And then whatever you have learned in terms of physics, right, as a part of either mechanical or computers, those come in, right? You can't do the other way around. Then what will happen is you will be working in a particular silo, and sometimes, the adjacencies would actually require more of your effort, which actually would contribute much better. So that open thought process of, okay, I have the skill sets, to which problem can I apply and solve? That's the key. Rahul, okay. So talking about EC and mechatronics, what do you prefer? Okay, you're asking my preference, Rahul. That's wrong question. I would say, what is your appetite, right? We talked about what mechatronics involves. You know how electronics and computer engineering is. Now, which one interests you? And the other thing is, if you pick whichever, It doesn't matter whether it's mechanical, mechatronics and all. The key thing is this will be your career for the next 30, 40 years, right? Think long term, see which are sustainable and say, and which interest you in the long term. See, in short term, it's something will interest you, but in long term, what is your long-term vision, right? Because when you pick an undergraduate program, you're picking a direction you want to go for the rest of your 30, 40 years of your career, right? It's not something like short term. So that's where we actually prefer the curriculum to be a bit generic and giving, avenues to pick. So like in mechatronics, we have 4 streams. You could pick one. In mechanical, we have 4 streams that you would like to pick and specialize a bit more. Like we have material and mechanics, we have energy, we have automotive and aerospace, and then we have mechatronics or robotics, right? Same thing with mechatronics. Do you want to get into healthcare applications or robotics, things like that? So there is an opportunity to be a bit generic at the start, and as you go along, based on getting more clarity within the first 2 years of your undergraduate program, you can pick one of this and then have that as your core area to grow and work in the next 30, 40 years, right? So the key thing is, yeah, you have to look at both and look at what you want to do 20, 30 years down the lane and see where you want to grow and choose between these two. Okay. So Rahul, no straight answer.